When we left off last time, we were talking about section 5.1 and we were talking about solving one-step equations with rational numbers. We went over a couple important details and then we went over 6 examples. And then I asked you to think about these problems right here, these questions right here. And it says, what is 4 less than 10? Now, most people know the answer right away. They know the answer is 6. And if somebody says, what is 5 more than 7, we stop and think for a second. We've got to do a little bit of addition. We end up with 12. But I want you to think about how you arrive at the answer for each one of those. So take a look at this one. We'll do this one first. This one says more than. So whenever we see more than, we're going to be adding something to whatever we had. So if you had $5 more today than you had yesterday, we would add $5 to whatever you had yesterday. So on this one, you can get away with doing this. You can do 5 plus 7 equals 12. But if you stop and think about what we were just talking about, if you had $5 more today than the 7 you had yesterday, what you would really do is you started out with 7 and you'd add 5. So this is really the type of problem that we're talking about right here. We're talking about having 7 and then we're doing 5 more than that. So we're adding 5. We're not adding 7, we're adding 5. So although you do arrive at the same answer, this is really what they meant when they said that. Now, that's not a big deal on this particular problem, but it is a big deal on this one right here because 4 less than 10. The answer is 6, and when we do less than something, we subtract. If you did 4 minus 10, you would not get 6. You would get negative 6. So this is not the right way. You would have to do this, 10 minus 4. So we started out with 10, and 4 less than that ends up being 6. This is the right way to do the problem. So the interesting thing about this is you can do this one either way. Addition is what we say is commutative. Commutative means that you can move the parts of an addition problem around and you get the same answer. That is not true with subtraction. So the only way to do this one is this right here, and the best way to do this one is this right here. So whenever you see the word than in a story problem or in context or something like that, that gives you a hint that you're going to switch the order. We're going to take the two of these, we're going to switch them around and do a subtraction problem because it's less. And we're going to take the two of these and we're going to switch them around and we're going to add them because it's more. So keep that in mind. So again, what we're talking about in this section, and this is part 2, is solving one-step equations in context. Now, these particular one-step equations, like we had yesterday, these have rational numbers in them, fractions, decimals, that sort of thing. Now, what I'm wondering is, do either one of these look familiar? After paying $5 for a drink, Addie had $38. How much did she have before buying the drink? Cameron won 112 bottles of soda at the school carnival. He then gave 4 to every student in his math class. He only has 8 bottles left. How many students are in his math class? Well, I'm hoping these look familiar because they're very, very similar to some that we've had on tests. They're also very, very similar to ones that we've had on assignments. So the way to go through and write down what happened here is, after paying for a drink, Addie had $38. How much money did she have before buying the drink? So let's declare a variable. We'll say that is money before, whoops, and I'm just going to write before. So money before. She had this money and then she paid for a drink. If she paid for a drink, that means she had to pay $5. That means her amount of money would have gone down. And then she would have ended up with $38. Well, then we can go through and we can solve that. So we can add 5 to both sides. So we end up with m equals 43. So $43. $43 is what she had before. We can do the same thing here. Cameron won 112 bottles. He then gave 4 to every student in his math class, and they only had 8 bottles left. So how many students are in his math class? So we'll say m equals number of students in math. And then let's stop and think about what happened here. He had 112 bottles of soda. Man, he got lucky at the school carnival. Then he gave 4 to every single one in his math class. So if he had only 1 student in his math class, he would have given away 4. If he had 2 students, he would have given away 8, 3 students, 12, and so forth. Well, what we're doing is we're multiplying the number of students in his math class by 4, and then we would subtract that because that's going to decrease from his total. He's got to give that many away. And then it says he only has 8 bottles left. So he was really generous. He had 112, so he decided to give 4 away to everybody, and then he's going to keep 8 for himself, and then we can go through and we can solve that. So if we subtract 112, we get negative 4m. Then over on this side we have negative 104, and then we're going to divide by negative 4. Negative divided by negative is positive. Same thing here, and 104 divided by 4 is going to be 26. So m equals 26, but remember what that means. That means that he's got that many students in his math class. So we're going to say 26 students is the answer to the question. Okay? Now, as we go through and solve some of these one-step equations in context, again, it's important to keep in mind that word than, that it gives us a clue as to how to do these. So whenever we see the word than used to indicate addition or subtraction, we switch the order, switch the order of the numbers. Switch the order of the numbers. So, like we set up above, we're going to do this problem right here. 4 less than 10, we're going to switch those, and we're going to do 10 minus 4, and our answer is 6. Same thing here. Even though we could get away with it the other way, we're going to switch the order because the word than is our key. So 7 plus 5, and we end up with a 12. So keep those in mind as we're doing some that are a little bit more difficult that have rational numbers in them. So it says write an equation that represents each of the following. Do not solve. So on this first part of the notes, and on the assignment for that matter, all you have to do is set it up. You don't have to solve. So let's pay attention to the words and to the punctuation. So it says the sum of 6 and a number is 1.4. The sum of 6 and a number is 1.4. Now the word sum means that we're going to add. So we're going to add 6 and a number. Now it doesn't have the word than in it, so we don't need to switch them. So we're going to do 6 plus a number, the sum of those two numbers, 6 and a number, is, the word is means equals. So equals 1.4. Now here's the cool part about this. If we don't have to solve it, we're done. All we need to do is translate that into an equation. We're finished. It says we don't need to solve, so we're done. Okay, 3/4 of a number. Remember the word of, we talked about this in a couple of other examples. The word of means multiply. So we're going to multiply these together. So 3/4 of a number. If we don't know what the number is, we're going to use an n to represent that, or you could use x if you wanted to. That would be fine. And the word is, again, represents equals. So this would be equals 20. And again, we're done because it says we don't have to solve this. We've got a rational number here, we've got a rational number here, but we've written these down in context, and then hopefully we'd be pretty good at solving these at this point. Okay, twice a number. So let's stop and think about twice a number. What happens if we get twice as much money, or twice as many hamsters, or whatever it happens to be, or twice as much recess time or something? Well, we'd get double that amount. So twice a number, so we're going to times it by the number, is, remember, is equals, and then equals negative 20.8. Now you'll notice that I put this in parentheses, and that's not a horrible idea, but most of the time we can get away with just that implied multiplication, having that coefficient of 2n, and that's it, because we don't have to solve it. We're done right there. Let's take a look at this one. 18.96 is, so there's an equals, 6.4 less than a number. There's our word than. Now if we have the word than, just like we did up above when we were doing those problems earlier, we're going to switch the order that we put these in. So we're going to have 18.96 is means equals, 6.4 less than a number. So we're going to take the number, we're going to use n for the number, and then we're going to subtract 6.4. Again, we're done with this. We don't need to solve it because the instructions said we didn't need to. Okay. Product of a number and 1/4 is 14. Product. Remember, a product is a multiplication problem, so it's telling us that we're going to take the number and 1/4 and we're going to multiply them together. So we're going to use n times 1/4, and it says is means equal, so is 14, and that would be the answer. Now I probably wouldn't leave it like this. We normally like a coefficient or a factor in one of those terms to show up in front of the variable, so we'd probably write it like this: 1/4 n equals 14. That would be one way to do it. Or another way that we could do this is, remember, we could multiply these together, kind of think of that as a fraction, and we could do 1 times n is n, and then 4 times 1 is 4. We could do n divided by 4 equals 14. We could do it that way. Both of those would be okay. Perfectly good ways to do that particular problem. Okay. All right, let's take a look at the next one. The next one says, write an equation that represents the problem, then solve. So we actually have to go through and solve this equation. So it says you spent $5.25, which was 1/4 of your allowance. How much was your allowance? So here's the question. We don't know how much the allowance is, so I'm going to use A for allowance. And then remember, the word of means multiply. So this is going to be 1/4 of your allowance, 1/4 times your allowance. So $5.25 is 1/4 of your allowance. So we've declared a variable. We've got the equation. This is what we would have had to do up above. And now it actually says solve. So we're going to go through and solve this. So I'm going to solve this. We've got a fraction in front of the variable. So what I'm going to do is I'm going to rewrite this over here. So I'm going to write 525 equals 1/4 A. And what I'm going to do is I'm going to multiply both sides by the reciprocal. Now, there's no problem with multiplying it at the back here. That's totally okay. So I'm going to cancel the 4 with the 4 and the 1 with the 1 if you want to write it that way. So we get A over here, and then we've got 4 times 525. If you want to throw that into your calculator, you'd end up with 21. So we've declared a variable, we've written an equation, we've solved the equation, and we got A equals 21, but then we need to put it in the context of the problem. How much was your allowance? So we would write allowance was $21. And there's the answer to the problem right there. Now, as you're going through and you're working on the assignment, I want you to keep these things in mind. There are a bunch of words that can translate into mathematical operations or statements and things like that. So if we're talking about addition, a lot of times we'll use the word sum or total or increase. We've seen the use of more than. Remember, the word than when we're talking about addition means we switch the order. For subtraction, a lot of times they'll use the word difference or decreased. They'll say the words less than sometimes, and again, that word than means we switch the order that they come in. Multiplication, we might say that it's a product. We might say they're factors. We might say things like double if we're multiplying by 2, triple if we're multiplying by 3, different things like that. And then the word of, just like we said up here, 1/4 of something or half of something, things like that. That translates into multiplication. Division, we might use the word quotient. We might say this many out of this or something like that, or we might use words like half or third or different things there. And then equals, a lot of times, this is what we use most of the time. Most of the time we say is for equals. Occasionally we'll say yields or the answer or something like that. So there might be some other weird words, but most of the time it's the word is. That's the one that comes up the most often. Now what I'd like you to keep in mind on this is this isn't a complete list. Okay, and these words will not work in all cases. So you can't just come back and say, hey, you said that this means this. You do have to be careful and read each one. So this list is going to give you a good place to start, but it's important that you think about what's going on in the context of the situation. So as you're going through and you're doing the problem, think about the context of the problem. And, does it make sense to be adding? Does it make sense to be multiplying or dividing, or what happens there? So figure out how to set up the expression or the equation to help you find the solution. And if you don't know a word in a story problem, then look it up. We've got lots of things now. We've got dictionaries, we've got Google, you've got your smartphone probably. So in short, sometimes you just have to use your brain. And that's a really good thing to do. Hopefully we're exercising our brains all the time. But if you can't figure out something out based on what we've talked about, see if you can figure out from context. Look up the words. See if you can make sense of those things. So on today's assignment, they're going to be somewhere all you have to do is just set up the equation like we did right here. And then they're going to be somewhere you actually have to set up the equation, declare a variable, all that sort of stuff, and then actually solve that equation. Sometimes you'll end up with an integer like we did here. Sometimes you'll end up with a rational number, but most of the problems will have rational numbers on them. So good luck with that.